All right, welcome to part 2 of this video series. We're looking at chapter 5.5, which is about the side-side-side congruence theorem. But also there's another theorem that's mentioned in this chapter, which is called the hypotenuse leg congruence theorem. Okay, let me write this down. So the hypotenuse leg congruence theorem. Okay, so this theorem applies to right triangles. And so it says that if you have two right triangles where you have a pair of congruent hypotenuses as well as a pair of congruent legs, and it doesn't matter which one, I'll just use the bottom one, okay, then that is actually enough information to conclude or claim that the triangles are congruent. Okay, so again, this only applies to right triangles. Okay, so you need to have a right angle to start with, and then if you can show that the hypotenuses are the same length and one of the legs is the same length, then that's pretty much all you got to show. All right, so question number 6, it says redraw the triangles so that they are side by side with corresponding parts in the same position, then write a proof. Actually, I'm going to skip that for now. Maybe we can come back to it at the end. Okay. So what we know is that point B is the midpoint of the segment CD, right? So B is in the exact middle of this segment here. Okay. Segment AB is congruent to segment EB. So you can already see that they have the single tick marks there. And then angles C and D are right angles, and you can see that those are already marked as such. So let's go ahead and write all that in, okay, into our first column here. So B is the midpoint of segment CD. Let's see, AB is congruent to EB, and then angle C and angle D are right angles. And we'll just write given. Okay, so that's all one statement there. Okay. All right, what we're trying to prove is that triangle ABC is congruent to triangle EBD. All right. So, so we see that we have right triangles. So this is a good candidate for the hypotenuse leg congruence theorem. Okay. We can see that in the diagram and also in the given statement that the hypotenuses of these triangles are already congruent. Now we just have to show that a pair of legs are congruent. Okay. So a lot of times if you see like a key vocabulary word, you're probably going to have to use the definition somewhere in the proof. So B is the midpoint of segment CD, right? So B is in the exact middle of CD, okay? So if it's in the exact middle, then B must divide this segment into two equal pieces. In other words, what I'm trying to say is that CB and BD are the same length. They're congruent, okay? Because B is in the middle, it's the midpoint. All right. So this is going to be our pair of congruent legs. The pink sides are the hypotenuses, which are congruent, and the blue sides are a leg. Right, so let's write segment CB is congruent to segment BD, and we'll write definition of midpoint. Right, a midpoint divides a segment into two equal halves. All right, so if we look at our figure, we have right triangles, okay? So that checks out here. We have a pair of congruent hypotenuses, so that checks out, and we have a pair of congruent legs, so that checks out. And that's all we need to show, okay? So by the hypotenuse leg congruence theorem, right, our two triangles are indeed congruent. Okay. So this statement here was about the hypotenuse, and that statement there was about the leg. All right, let's redraw the triangles. Okay, so I'm going to draw them this way. All right, so this would be A, B, C, and then this one I'm going to reflect it. Okay, so E is the most acute angle, D is the right angle, and B is the other acute angle. Okay. So it was the hypotenuses that were congruent and the short legs that were congruent. Okay. So this is what it looks like when you take the two triangles and you just redraw them so that they're in the same orientation. All right, so let's just make sure that the naming checks out. So we have A, B, C, and E, B, D, and those letters are in the same order. All right, I'm going to stop this video. We have one more proof, but I'm going to do this in a second video. This one looks like it's going to be a rather long proof.